The Sun, a giant star. It formed 4.6 billion years ago in a giant spinning cloud of gas and dust called the solar nebula. Gravity concentrated 99.8% of the gas and dust in the solar nebula to form the Sun. The rest of the material created the planets and other objects that orbit the Sun. The Sun is the ultimate source of energy. Life on Earth depends on it. Plants use sunlight for photosynthesis. Animals get energy by eating plants or other animals that eat plants. The Sun is a fascinating object. It is a giant ball of hot gas. It is constantly changing. The Sun, our closest star, is a massive ball of glowing gases. It is primarily composed of hydrogen and helium. These two elements, hydrogen and helium, are the lightest and simplest elements in the periodic table. They are also the most abundant elements in the universe, making up the majority of the observable matter. Deep within the Sun's core, hydrogen atoms undergo a process known as nuclear fusion. During nuclear fusion, hydrogen nuclei combine to form helium, releasing a tremendous amount of energy in the process. This energy is released in the form of light and heat, which radiates outward from the Sun. It is this energy that makes the Sun shine so brightly, providing light and warmth to our solar system. The Sun's surface is a turbulent place, with heat waves, solar storms, and flares erupting frequently. At its core, the Sun reaches temperatures of about 27 million degrees Fahrenheit, an unimaginable heat. The Sun is constantly losing mass through the solar wind and mass ejections, a process that has been ongoing for billions of years. This mass loss occurs because the Sun is converting its mass into energy through nuclear fusion. But don't worry, the Sun has enough mass to continue shining for billions of years, ensuring the stability of our solar system for a long time to come. The Sun has an atmosphere, just like Earth. It is made up of several layers. The outermost layer is called the corona. The corona is much hotter than the Sun's surface. It can reach temperatures of millions of degrees. Scientists are still trying to understand why the corona is so hot. The corona is also where solar wind originates. Solar wind is a stream of charged particles. It constantly flows from the Sun. Section 4. Solar wind. The Sun, our closest star, is not just a source of light and heat. It also emits a powerful stream of particles known as the solar wind. Solar wind is a constant stream of charged particles, primarily electrons and protons, that flow outward from the Sun. It flows from the Sun in all directions, filling the entire solar system with a sea of particles. These particles travel at incredible speeds, reaching hundreds of miles per second, making the solar wind a truly dynamic force. Solar wind is made up of electrons and protons, the building blocks of atoms, which are constantly being ejected from the Sun's outer layers. These particles are electrically charged, meaning they carry an electric charge as they move through space. They carry the Sun's magnetic field with them, creating a complex and ever-changing magnetic environment in space. Solar wind can interact with Earth's magnetic field, causing a variety of effects on our planet. One of the most beautiful effects is the creation of auroras, stunning light displays in the polar regions. However, solar wind can also disrupt satellites and power grids, leading to communication issues and power outages. Solar wind is a powerful force, constantly shaping and influencing the space environment around us. It shapes the environment of our solar system, affecting everything from planetary atmospheres to the behavior of comets and asteroids. Section 5. Journey of the solar wind. The Sun, our life-giving star, is constantly active, emitting streams of charged particles known as solar wind. Solar wind travels far and wide, journeying through the vast expanse of space. These particles are propelled by the Sun's intense energy. It travels at incredible speeds, sometimes reaching up to 800 kilometers per second. This high velocity allows it to cover immense distances in a relatively short time. It can reach the outer edges of our solar system, influencing planets and their magnetic fields along the way. The solar wind's journey is a testament to the Sun's far-reaching influence. As solar wind travels, it expands and cools, losing some of its initial energy. This cooling process is crucial for its interaction with other cosmic elements. It also interacts with the interstellar medium, a vast region filled with gas and dust particles. These interactions can create shock waves and other fascinating phenomena. This is the gas and dust that exists between the stars, forming a complex and dynamic environment. The interstellar medium plays a significant role in the life cycle of stars and planetary systems. Solar wind creates a bubble around our solar system, known as the heliosphere. This bubble acts as a protective shield, This bubble is called the heliosphere. It marks the boundary where the solar wind's influence wanes and interstellar space begins. It protects us from some of the harmful radiation from interstellar space, ensuring that life on Earth can thrive without being bombarded by cosmic rays. The journey of solar wind is a testament to the sun's power and influence. It reminds us of the dynamic and interconnected nature of our solar system, and the vital role the sun plays in sustaining life on our planet. Section 6. The sun's influence. The sun is a powerful force. It shapes our solar system. It provides the energy for life on Earth. The sun's gravity holds our solar system together. Its light and heat make life possible. Its solar wind creates auroras and affects our technology. The sun is a fascinating object. It is constantly changing. Scientists are still learning about its secrets. One thing is for sure, the sun is essential to our existence. Pause 2S. Section 7. Sunspots. The sun's blemishes. Sunspots are temporary phenomena on the sun's photosphere that appear as spots darker than the surrounding areas. They are caused by the sun's magnetic field welling up to the photosphere, the sun's visible surface. Sunspots usually appear in pairs of opposite magnetic polarity. They can last for days to weeks and are often associated with solar flares and coronal mass ejections. These enigmatic blemishes on the sun's surface provide scientists with valuable clues about the sun's magnetic activity and its impact on space weather. Understanding sunspots helps us predict solar storms and protect our technology on Earth. Pause 3S. Pause 2S. Section 8. The wonders of solar eclipses. A solar eclipse occurs when the moon passes between the Earth and the sun, blocking all or part of the sun's light. This can only happen during a new moon, when the sun and the moon are in conjunction as seen from Earth. Pause 2S. There are 3 types of solar eclipses: total, partial, and annular. Pause 1S. During a total solar eclipse, the alignment of the sun, moon, and Earth must be nearly perfect, causing the moon to completely cover the sun. This results in an awe-inspiring moment of darkness during the day, revealing the sun's corona, a rare and mesmerizing sight. Pause 2S. In a partial solar eclipse, only a portion of the sun is obscured by the moon, creating a crescent shape of sunlight. These partial eclipses are more common but still offer a spectacular view. Pause 2S. An annular solar eclipse occurs when the moon is too far from Earth to completely cover the sun, leaving a ring of sunlight known as the Ring of Fire. This phenomenon is both striking and unique, captivating observers with its celestial beauty. Pause 2S. Eclipses have fascinated humanity for centuries, inspiring myths, scientific curiosity, and a sense of wonder about our place in the universe. By studying solar eclipses, we gain deeper insights into the dynamics between the Earth, Moon, and Sun, enriching our understanding of the cosmos. Pause 3S. In about 5 billion years, the Sun will exhaust its hydrogen fuel and enter the red giant phase. It will expand and engulf the inner planets, including Earth. Eventually, the Sun will shed its outer layers, leaving behind a hot core that will cool and shrink into a white dwarf. This process will mark the end of the Sun's life cycle. Pause 2S. This transformation, though billions of years away, is a powerful reminder of the ever-changing nature of our universe. The Sun, which has nurtured life on Earth for billions of years, will one day become a distant memory in the vast expanse of space. Pause 2S. However, this end is not a final goodbye but a part of the cosmic cycle of birth, death, and rebirth. As the Sun fades, it will leave behind elements that may one day become the building blocks of new stars and planets, continuing the grand ballet of the cosmos. Pause 2S. The Sun's final act is a poignant chapter in the story of our solar system, a testament to the incredible forces that shape our universe. By understanding this process, we gain a deeper appreciation for the delicate balance that sustains life on our planet, and the intricate dance of celestial bodies that govern our existence. Pause 3S. The word sun comes from the Old English word sun, which has its roots in the Proto-Germanic word sunun. This in turn is derived from the Proto-Indo-European root sofel, which is also the source of the Latin word sol, and the Greek word helios. The sun has been a central figure in many cultures and languages throughout history. From ancient myths and legends to modern scientific understanding, the sun has inspired awe and reverence. In ancient Egypt, the sun god Ra was considered the king of all gods, a symbol of life and creation. The Aztecs worshipped the sun god Tonatiuh, believing that he required human sacrifices to continue his journey across the sky. In Hinduism, the sun is personified as Surya, a deity who rides a chariot pulled by 7 horses, representing the 7 colors of the rainbow and the 7 days of the week. The sun is also central in many Native American cultures, often seen as a powerful and benevolent force. Even today, our language and traditions reflect the sun's importance. From the celebration of solstices to the use of solar energy, the sun remains a vital part of human existence. It's a reminder of our connection to the cosmos and how our ancestors looked to the sky for guidance and inspiration. As we continue to explore and understand the sun, we also honor the rich tapestry of culture and history that has been woven around this brilliant star. The sun not only sustains life on Earth but also illuminates the human spirit and our quest for knowledge. Pause 3S. And so as we gaze up at the sun, we see not just a fiery ball of gas but a symbol of continuity, connection, and the enduring legacy of our shared human experience.